for extractive gas monitors, because otherwise I have far too high manual maintenance to do. I have to find a representative point for the inlet of my probe. So vertical, here in India it's 8 times or more, 8 times diameter or more before and 5 times diameter after. Definitely not too close to the outlet, and the horizontal position should be somewhere between 15 and 50% of stack diameter. Why not closer to the wall? In large stacks, you see an airflow from the stack outlet along the walls, an airflow coming down. So you have completely different situation directly at the wall in the first, let's say, 5% of the diameter. You have different flow direction and you have a relatively clean airflow. Very, very important on sample handling systems, no cold spots. Any cold spot which is there creates condensation. Any condensation creates not only corrosion of my system, it also creates or dilutes or takes out components I want to measure. So any cold spot has to be avoided. And I mean, we've seen pictures from what Sanjeev showed yesterday. I mean, you could just see the cold spots in these negative examples. So that is a very important part. No cold spot from the outlet of the stack until the inlet of the sample gas cooler. Yes, if we have very long heated sample lines, very long umbilicals, because we have a large distance, possibly use a bypass pump and use a higher diameter of umbilical of the sample transport line in the umbilical, so that you get the higher quantity of gas with this bypass pump down to the analyzers in order to reduce your response time of the overall system. Because if you take too low flow, you're creating a differential pressure. If you use a 1/4 inch or 6 mm tube and you have a 50, 60, 100 meter umbilical, you're creating a significant differential pressure, and your sample gas pump might not even be able to really scope with it. So you're not getting enough gas through. So use a bypass pump and go to a larger diameter, 3/8 inch or 12 mm or whatever. In order for the traveling time through the umbilical. And then there is an outlet, an effluent from the sample gas cooler. The effluent from the sample gas cooler is very acidic. We're talking about typically pH 1 to pH 2. Very acidic. So not just let it drop out on the ground. Include it in the planned effluent, which is handled correctly. Why is it acidic? Because some components are water soluble, SO2, NO2, and they to some extent get dissolved in the condensed water in the heat exchangers. We're coming to that. So, detection technologies. SAMs. They're basically, as we've seen, there are 3 principal design possibilities. One is directly in situ analyzers. A directly in situ analyzer that is possible for dust, oxygen, zirconium dioxide probes, CO, CO2, SO2, cross-check, and also for mercury. For elemental mercury, however, only, not for total mercury. Coming this afternoon to what is the difference between elemental mercury and total mercury? Why do we need to measure total mercury? And that these in situ instruments are either a probe measurement or cross-stack measurement or point measurements. Conventional extractive analyzers, they take out the sample. That is possible for dust. As we have seen, Sanjeev showed the extractive beta gauge this morning, or the extractive light scattering instrument for wet stacks. This is for dust. Then all the gas components, total mercury, total hydrocarbons, dioxins and furans I mentioned here. And as you see the words in the brackets behind, we're talking about nanograms per cubic meter, what needs to be detected, so there are no analyzers around. It's quote, quote, only samplers. And of course, oxygen and humidity. The dilution-based extractive analyzers, they work, yes, for dust as well. The instrument, what we've seen this morning, plus other extractive instruments, they work with an additional dilution. SOx, NOx, total mercury, these are typical dilution-based extractive analyzers where I have a dilution gas. Dilution gas has a dew point of, let's say, 0 centigrades, and I dilute 50 to 100 to 1. And through the critical orifice, I'm getting, when the orifice is critical, I'm getting a constant flow of sample gas, and with the variations of my dilution air, I can vary my dilution factor and stabilize my dilution factor by controlling my dilution air. Detection technologies itself, infrared, very widely used because many pollutants we want to see, they have one or more absorption bands in the infrared scale, so that is what can be done there. But there are other technologies. There is UV absorption, there's chemiluminescence. We heard that already several times. FTIRs, also there are IR spectrometers, but they scan the IR scale, so they are multi-component analyzers. Tunable diode laser absorption spectroscopy, which is more or less or cascade analyzers, they're more or less the newest technology in emission monitoring. Then FIDs, flame ionization detectors, for detection of total hydrocarbons, because total hydrocarbons, that's a summary of hundreds, thousands, or whatever components, carbon-based components, so organic, not inorganic carbon-based. Inorganic carbon-based is CO and CO2. Organic carbon-based is everything else. And the FID measures that in a summary signal. Or if I want to see individual hydrocarbons in my emissions out of whatever reasons, or in a process monitoring, even more important, I want to see an individual hydrocarbon, then I'm looking into gas chromatography. Then UV photometers, or cold vapor atomic fluorescence spectrometer, or atomic absorption spectrometers, that's used for mercury. And then, as already mentioned, zirconium dioxide probes for oxygen. Now, I have an in situ SEMS. Point measurement, cross-stack measurement. That's the path systems and point systems. Now, what are the advantages and disadvantages of that? Number one, I do not touch the sample gas. I leave it where it is. I analyze it where it is in the stack. I don't need a sample handling system. I don't have to transport the sample gas to the measurement. I do not have any loss of material. Typically, there are multi-component analyzers, so typically in a multi-component analyzer, if one component fails, then I lose all data. If I have individual analyzers in a SAM system, if my NOx analyzer fails, I still get my CO and my SO2 and oxygen, etc., giving me data. Disadvantages, there might be interferences inside the stack, which I don't know. Interferences in the wavelengths with components I don't know. Very important, my reporting is required on dry basis. An in situ analyzer, like a dust monitor, or like gas analyzers, they work on wet basis. So I have to correct them for moisture content, because the moisture in the stack is a diluting factor. After I take out the moisture of the stack, calculate it out, my concentration goes up automatically. Sensitivity, path length, stack diameter, very important point, because my path length goes into the sensitivity of my system. And the longer my path length is, the lower is my lowest detectable concentration. Maintenance and service up there. So provide for a good platform, provide for a good monkey ladder with safety, so that people can safely reach there. Nevertheless, I know it from myself when I was in service. That was not my preferred location, call it that way. When we talk, which is not for thermal power plants, more for refineries, petrochemical plants, when we talk about hazardous areas, in situ instruments very often are not available for hazardous area locations, not with PESO or CCOE certificate. Extractive, conventional extractive, as we already saw, sample probe, umbilical, sample gas cooler, pump, condensate detector, maybe calibration valve here, and some protection for the analyzers, and then the analyzers. Or if I can convince my authority and she says no, or they say no, you don't really need continuous data for every of your stacks because your emissions are so low, you can go for a multi-point system, either a heated multi-point system, so one set of analyzers measuring multiple stacks, or an unheated, where I have the sample gas cooler before that, and then have my cool down sample going through the multi-point sequencer. But again, now if I look at that, I get only 33% of the time data per stack. Very clear. So that is only if the authorities accept that. Then we can do that. Typical system looks very the same. Sample probe, heated umbilical, we've seen that before. In this case, it's a European type. Sample gas cooler, going the calibration gas either there or to the analyzers, and all the valves, and etc., what is required. Calibration gas typically goes through the umbilical, so that's umbilicals with two lines, two tubes. One is heated for sample, and the other one is unheated for the calibration gas. So I get my calibration gas up to the stack and my heated sample gas down to the analyzers. So what's the advantage? Simple. We can easily span check and zero check. I have to change that calibrating. Zero check and span check the entire SEMS. We have individual analyzers, as already mentioned. Service and maintenance for the analyzers is in the instrument shelter, not up on the stack, only for the sample handling system. And I'm taking out the condensate, so means my measurement is on dry basis already. So I don't need to correct my gas analyzer data for the humidity, only my dust monitoring data. Yes, but I need an AC shelter. Specifically here in India, better have that. Or an area which is air conditioned so that the instruments, I mean, analyzers like it from, let's say, 5 plus 5 to plus 45 or plus 50. That's about it. So not really good to put them outside an AC shelter. Sample handling system, service maintenance is at the tapping point. In sample gas chillers, I'm losing components. Yes, that is the case. SO2 is water soluble, NO2 is water soluble. No way to do an ammonia analysis or HCl analysis or HF analysis with a sample gas cooler. Now you're producing very good zero gas, so and everything is in the effluent. But these have to be hot temperature or dilution-based instrumentation. And it depends on the design of the heat exchangers, how much of the sample gas is or components are diluted or soluble. And again, sample handling system should be very good designed to match the application. Last, in situ dilution or ex situ dilution. Very simple to calibrate it because I introduce a calibration gate at the dilution probe. I calibrate the analyzers, including the dilution factor in one step. I have no loss of water-soluble compounds, no washouts. I do not need any heated umbilicals, so very significantly lower cost factor, especially when we come to long heated sample lines or long distance. I have individual analyzers, and the service and maintenance for the analyzers is in the AC shelter. I again need an AC shelter. Okay, my dilution probe service maintenance is at the tapping point. But now I'm not only diluting my water, I'm also diluting the concentration. That means my analyzers have to be more sensitive. Most likely I have to go to air quality concentration-based analyzers, and they're more expensive than the typical SEMS analyzers. So that can be a significant disadvantage, specifically when it comes to the investment cost. If my dilution is not stable, of course, then I have problems with the accuracy. And last but not least, like with in situ analyzers, I measure on wet basis because I leave the water in it. I just dilute it so that it reaches a sample gas. The diluted sample gas reaches a dew point of approximately 2 1, 2, 3 centigrades, maybe 4 centigrades. So I need to have my humidity measurement, and I have to be sure, I have to be clear when I calibrate, my calibration gas does not include any humidity, so my calibration is on dry basis, whereas my measurement is on wet basis. These were the guys from whom I stole a couple of the slides, or which helped me creating that. Thanks, that was it. Thanks for listening. Any questions? Do we have the second? Oh, it's there.
Sir, we have a stack of 275 meters, and my analyzer is sensor is at 43 meters. Where is the ideal location for the analyzers to be kept? My sensor is at 43 meters, and analyzer is at ideally 0 meter.
Do you have a platform?
Yes, we have a platform at that.
A sizable platform.
Yes, it's a sizable.
Then I mean, from the point of view of accuracy, best point is up there. Put a small shelter, air-conditioned shelter on the platform, and have a very short heated umbilical. If you cannot do that, then have the AC shelter just at the bottom of the stack and have a round about 50-meter umbilical running down the stack.
But the only disadvantage at 0 meters is that maintaining the sampling line.
Sampling, heated umbilicals typically don't require maintenance. They either work or they don't work. So in the annual maintenance, yes, you might run a solvent through it just to clean it, but that's a once per year or maybe once every 2 years event, and that doesn't take a lot of effort.
But the disadvantage is that we are using air as purging, and taking air to that top is developing a moisture, a cold content, which is reacting with the sample and developing punctures in those lines.
Why is your air, your purge air developing moisture when it comes to level 43?
The air is not that.
Okay, yeah, but then you have to dry. You have to have a dryer, and you can just add an automatic dryer, which automatically switches between two drying areas, and first one dries, the second one is cleaned at the same time, and then it switches backwards. So that then will solve that problem.
Thank you.
Welcome. Any more questions? If that's not the case, I'm happily closing my lecture here, and but I'm still here today, tomorrow, Friday, so anything what comes up, just touch base with me. Thank you.
Final call. How many people are going for the site visit? Just raise your hands. Everyone? Okay. 1, 2, 3. Counting? You people get disturbed again. So we can start from here. Sir, 1, 2, 3. This row. 14 या आप सर 14 के बाद आपका है आपका 20 आपका 23 then पीछे 48 49 50 51 52 53 54 55 56 7 8 9 10 11 12 13 14 65 so tomorrow what we are going to see I mean we have people from the plant itself unfortunately they have a in situ equipment they do have a lift but it's a captive power plant we do have a lift in situ is installed so unfortunately everybody will not be able to manage to go on the top. It's not safe as well. You have seen we can show the equipments over there. But we have a place where the next session when it is going on the manual monitoring. So we will try to demonstrate it in the duct, do all those calculations etc. We'll see the data handling, how the data etc. is coming. The plant is also not working because of the coal shortage, but that we have nothing to do with that. We have to see how things work, right? So some of us who is too interested to go on the top can go, but I think everybody will not be interested. I mean, okay, yeah, some of us can go, but it is not safe to for everyone to go on the top. So it's a small lift. So that's fine. So our plan is we will have a bus here at this point of here available. We will leave sharp 8, sharp 9. So you can have your internal target of 8, 8:30, 7:30, whatever you are comfortable with. So after 9, you will not see the bus here. That's my point. So we'll go to the site. We'll do all that. We'll have a packed lunch that we have to take from here mostly. So we will have the lunch, and after that, by the lunch time, we'll be finished. Then we'll go. Probably we'll try to visit Vimbetka nearby the site, and we'll do that trip, and then we'll come back, and you will be free. Day after, the agenda that works for half a day, we'll do that. Right? Things clear. Safety shoe not mandatory, but if you have a shoe, it is good. We should have ideally, right? That's it. Over to you, Son.
Good morning. Okay, so I'm going to discuss some basic approaches for U.S. SIMs according to U.S. EPA. So, all coal-fired boilers and integrated gas-fired combined cycle combustion turbines must use SIMs to monitor gas concentrations and gas flow rates to determine SO2, NOx, and CO2 emissions and heat input. Gas and oil-fired boilers and turbines typically use SIMs, a NOx SIMs diluent system, which has CO2 or O2 to measure NOx emissions rates. Gas and oil-fired boilers and combustion turbines typically use hourly data from a NOx diluent system together with heat input rates to determine NOx mass emission rates. Heat rates can be based on fuel analysis and certified flow meters. So for combustion turbines, you do not have to have a flow monitoring system. You can use the fuel flow rate and a certified fuel flow meter, and you take that fuel flow rate and the gas analysis, which gives you a caloric value or a higher heating value, and you can calculate your mass emissions with the pollutants that way. So this is just a very remedial drawing of what a SEMS system may look like. But the point of interest here is because in the US we typically have to measure flow rates, especially on coal-fired boilers. you can see that we have ultrasonic flow meter on that stack. So you're measuring the ultrasonic flow meter. You can either use ultrasonic or you can use an S-type pitot, depending on your stack configuration. Ultrasonic monitors are limited on their insertion depth. So if you have extremely long port depths, you would not be able to use that. So you would use an S-type pitot. In areas where you could have very turbulent flow, such as after FGD, once you install multi-vessel FGDs, for example, you can get some very interesting flow configurations as you shift between vessels. To help accommodate that and reduce the amount of cyclonic or turbulent flow measurement and improve the accuracy, we typically use 2 ultrasonic flow systems in a pattern that's very much like, we call it a lazy X system. It's not perfectly perpendicular, but it's off. And what that allows you to do is measure in 2 different directions and help minimize turbulent or cyclonic error that you may encounter. So the placement of the sampling probe is a little bit different. We're not quite as prescriptive. I mean, there are some ideal measurements. You would like to ideally place it at maybe 8 and 2, 8 diameters upstream and 8 diameters downstream and 2 diameters upstream. However, the placement of the sampling probe, according to the EPA, allows for you to place the probe at a representative point. Install the pollutant concentration monitor or monitoring system at a location where the pollutant concentration and emission rate measurements are directly representative of the total emissions from the affected unit. Select a representative point or path for the monitor and probe so they will pass a relative accuracy test. So you had seen some pictures that Sanji had, and where you've got some kind of goofy configurations. Well, sometimes you don't have any other choice. The station's been there forever, so you need to measure. So as long as you can do a characterization of that duct, you do some initial testing, and you determine that there is minimal stratification, or that the average would give you a representative point, then you can use that location. But it's on the owner of the facility to prove that that location is an adequate location. For point monitors or in situ, locate the measurement point within the centroidal area of the stack or duct cross section, or no less than 1 meter from the stack or duct wall. Another consideration, it is suggested that the measurement location be at least 2 equivalent diameters downstream from the nearest control device, the nearest point of pollution generation, or other point at which a change in the pollution concentration or emissions rate may occur, and 2, at least 0.5 equivalent diameters upstream from the effluent or exhaust of the control device. So this gives you a little bit of a buffer between where you have a transition in a duct, and in this case, EPA method 1 would have you go from the nearest disturbance, which is a transition or a turn or some change in the duct dimension. But this is allowing for you to go from the actual exhaust of, say, your FGD, which is a little bit different. So you can be closer to the FGD exhaust than you would maybe on a stack, right? So if you had a ductwork location that may be reasonable and be able to provide you with a representative location, then you could use that. Continuous opacity insulation. So in the United States, we take things a little bit differently. We don't typically measure opacity after an FGD. So if we have an FGD in place, we are required to have an opacity monitor between the dust control and the FGD. So we install the comms at a location where the opacity measurements are representative of the total emissions from the affected source. 4 duct diameters downstream from any disturbance and 2 duct diameters upstream from any disturbance. And where the presence of condensed water vapor is not present. Additionally, installed comms must be accessible for maintenance. The other thing that we use the comms for is we use this on an opacity percentage. We don't try to correlate that with a mass rate. So this is an EPA chart that shows you an ideal non-particulate traverse point selection. And this equation gives you the equation for the equivalent diameter calculation for rectangular ducts according to the US EPA Method 1. So you can use these in conjunction to find the ideal point or ideal location. If you have enough run to do it, then you would find a laminar, in theory it would be a laminar position to test from. So establishing a monitor range and span. So this is very prescriptive according to Part 75 in the US EPA. So your maximum potential concentration applies to SO2, NOx, CO2, and O2. Now you can determine this either by using equations from fuel analysis, for SO2 for example, SEM's historical data from uncontrolled sections. So if you were to install an FGD on your facility, you should be able to go back and look at your previous historical SEMS data where you weren't controlling, and you could derive maybe a maximum potential concentration off of that over years of data. Or you can use table values that are provided in, say, AP42, which is a selection of emissions factors that have been put together by the US EPA for specific sources. The maximum potential concentration, or MPC, is used to determine the span and range of a SEMS analyzer, and when required is also used as a worst case for substitute data value. We also have MEC, or maximum expected concentration. This applies to units with add-on SO2 or NOx emissions controls. This represents the maximum controlled value for NOx and SO2. The initial maximum expected concentration determination is based on an expected average design removal efficiency. Certified SEM data, 720 hours or more, so that's 1 month or more of data, downstream of control device may also be used to determine the maximum expected concentration, provided the unit and the controls are both operating normally. So what this helps you determine with the maximum expected concentration is it's going to allow you to set the normal operating range for your instrument. Yesterday I briefly talked about dual range instruments, and we talked about it some earlier, where if you have a situation where your operation, all of a sudden you get really high concentrations and they go up, you can set it up for dual range. This allows you to capture incidents that exceed your normal operating range. Well, in this case, the MEC will be used to determine that. You have the maximum potential emission rate. This is used for substitute data purposes. Now, we provide emissions rates to the EPA and to the states. We have permit limits that are using pound per hour and pound per million BTU type emission calculations. These calculations are incorporated into our permits, so we have to provide that information to the authorities. They are calculated using the NOx, for example, NOx MPC and minimum CO2 or maximum O2 concentration, depending on what type of SEMS you're using. We also have the maximum potential velocity, which is used to calculate the maximum potential stack flow rate, which is used in conjunction with that to calculate a worst case scenario. We have a maximum potential flow rate, which is calculated using the MPV and the cross-sectional stack area. So high span values are determined based on a multiplier of 1.0 to 1.25 of the maximum potential values, i.e. maximum potential concentration or maximum potential flow. Dual span and range, high and low, are typically required for units with emissions controls, and low span is derived from the MEC. So that means if the control device should go offline for some reason, or there's a condition upset where you would have to bypass that control device, then you are still able to provide SEMS measurements and concentrations and mass rates to the regulatory agencies. The full-scale range must be equal to or greater than the span value. Typically, in the United States, and I would think most instrument providers would tell you this, that you want to be between 20% and 80% of the electronic range of the instrument for your span, so you stay out of the low and high end where there could be the potential for noise. Range exceedances may require a readjustment of the analyzer. So if you have a system change or you install the instrument in good intentions and you have, an ideal, this should be the maximum potential concentration. However, you find in normal operation that, or even in an upset condition, that you're exceeding that, you can go back and make adjustments and adjust the range. In fact, you are required to do so on a periodic basis, evaluate that. So as discussed previously, the certification process, we have to submit an initial monitoring plan and notification of SEM certification at least 21 days prior to the start of certification. We have to conduct all required testing for SEM systems to be certified. Those include 7-day calibration error test, linearity check, cycle time test, RADA and bias test, and data acquisition and handling system verification. The initial certification in the United States must be completed within 180 days after a new acid rain program unit commences commercial operation. The acid rain program is the program in which Part 75 was set up. For a newly affected acid rain program unit, testing must be completed within 180 days after the date that the unit becomes affected, which means a startup. For non-acid rain program units subject to Part 75, testing must be completed by the date specified in the applicable regulation. So we have several layers of regulation that apply to our units. So if there is an underlying or overarching subpart under Part 75 or Part 60, then we would have to conform with that. Upon completion of all certification tests, the monitoring systems are provisionally certified until approved by the regulatory agency, whether that's the state or the EPA. If the state has delegation, then they can approve the monitoring systems and the certification results. A certification application must be submitted within 45 days after completing all certification tests. This includes all data relevant to the certification. The administrator has 120 days after receipt of complete certification application to review the application and approve or disapprove. So it is always going to be up to your regulatory agency to decide whether or not you have conformance. This is an example from a monitoring plan data flow, which we have to include to the EPA and to the regulatory agency to show how the data is gathered and processed in a general sense. So you can see we have two systems. We have primary analyzer and a redundant analyzer. We have SO2, NOx, CO2. These are fed to data loggers, individual data loggers, so you have complete backup system. That is fed to the station computer. From the station computer, we have a network database that provides backup and data storage for long-term usage. We have a fleet reporting tool that is a database which is used for reporting to the EPA. After we have this information together, on a quarterly and annual basis, we have to provide reports to the appropriate regulatory agencies. Typically, that's through the state agency and then to the EPA. We have a remote interface that is located in the unit control room. So what you'll notice here is that there is no external connectivity outside of the facility. It's all kept within the fence line of the station and the company. So we do not report directly to our state agency as you guys do. They do not see that data until we see that data and we QA it and provide it to them in the appropriate reporting format. Data processing and calculations. Units with SO2 SEMS, on a wet basis, we calculate SO2 mass emissions rate in pounds per hour as follows. So we are allowed to use on a wet basis if we are using, say, in situ, or if we typically use dilution or extractive dilution systems. So our flow is measured on a wet basis, our pollutants are measured on a wet basis, and our diluent is measured on a wet basis when we use extractive dilution. So therefore, we can calculate an emissions rate without having to convert to dry. Nearly all units with NOx diluent SEMS calculate NOx emissions rates using either of these two equations. So one is O2 based and one is CO2 based. Again, that can be wet or dry depending on the type of system you have. Data capture and reporting of hourly averages. Historically, we collect data on a frequency on 1 minute averages. Those 1 minute averages are kept for approximately 3 hours, and then they are generated into 1 hour averages. And those 1 hour averages are used to report accordingly to the permit and the regulatory guidelines. That can be a 1 hour average, can be a 3 hour average, can be a 4 hour average. It really depends on the regulation. Hourly averages are computed using at least one data point. So this is also a little bit interesting. I know that David talked about the EU system or using a minimum of 40 minutes that they had to have a valid hour, right? Which is a little bit different here. So we are required to have 15-minute quadrants. We have to have at least 1 minute in 2 different 15-minute quadrants. So we calculate on a 1 minute average in each 15-minute quadrant of an hour in which fuel is combusted. If a unit operates more than one 15-minute quadrant of an hour and some of the emissions data are unavailable as a result of a QA/QC or maintenance activities during that hour, an hourly average may still be computed if there are at least 2 valid data points separated by a minimum of 15 minutes. So this is a little interesting because we have to be careful for data availability. We have very high data capture rates, but the reason we do is because we actually have our technicians who maintain our equipment. We have them watch the clock. So they would they would conduct a linearity. They would say, do the first set of injections. They would try to accomplish that they would start after the top of the hour, so they have their first minute, and say it takes them 30 minutes to do the 3 injections, and they could capture 1 other minute in the last 15 minutes. That gives them a valid hour. They can proceed into the next hour. Yeah, it adds time to how we actually perform some of these QA tests. I mean, sometimes you just don't have an option. You're going to lose that hour. But this gives you an option to salvage that as long as you're paying attention to how you are conducting your business. An owner or operator must use all valid data recorded during an hour to calculate the hourly average. All data points collected during an hour must, to the extent practicable, be evenly spaced over the hour. So in the example that Roland gave with using a timeshare, so if you have 3 units and they're all cycling through, you're sampling from 3 separate units over a period of time and they're switching between the units as a timeshare, but you are still required to have an equally distributed amount of data across that hour for each unit. This is also another point that is interesting to the US or unique, as far as I know, missing data. For any operating hours in which the quality assured data are unavailable due to maintenance, QA tests, or out of control periods, substitute data must be reported in accordance with the regulation. For SEMS, substitute data values become more conservative, trending to increase reported emissions as the percentage of monitor data availability decreases. So your PMA is the ratio of the number of quality assured hours to the number of operating hours over a specified period of time expressed as a percentage. When 8,760 unit or stack operating hours have been accumulated after initial certification, the PMA is calculated by the DAS on a 8760 hour rolling basis, updated hourly. So once you get 1 year of operation on a unit after you've certified, you are continuing a rolling average for that data. So incidents that may result in missing data: monitoring system malfunctions, critical component failure, monitoring system out of control due to a failed QA test, such as a daily calibration, which is a calibration error, as was stated earlier, linearity check, or RADA. If you fail any of those during any of those activities, then you are out of control, and you are reporting invalid data, and you will do data replacement or conduct data replacement. A required QA test is not performed by the deadline, so if you actually go past your required deadline, your data becomes invalid 1 hour after you've gone past that deadline. Monitoring system offline for routine maintenance or required QA/QC activities, which is why we try to watch the clock and minimize the impact there. While you may not be able to do something with unexpected maintenance, with routine maintenance, you should be in control of how you manage your time. Improper application of the Part 75 regulation or associated policy guidance, which means if you did not follow the rules and for some reason you didn't find that out until X time passed, you're going to lose all of your data to the previous valid hour. So we have electronic reporting in the United States, but we don't have it directly fed to the agency. So we have, the EPA has an emissions collection and monitoring plan system. ECMPS is a desktop application. So affected sources are required to use ECMPS client tool to make 3 types of submissions: monitoring plan information, which I said yesterday is a living document, so as things change with your system, you would update that, and then you would submit it through ECMPS. Certification, recertification, and QA test results. So linearity tests, RADA tests, all of that gets submitted through there, in addition to initial certification and recertification. Quarterly emissions reports. So we report at a minimum on a quarterly basis. Those reports are typically due within 30 days from the end of the quarter. And those are submitted electronically as well as in hard copy on occasion to the regulatory agency. Certification, recertification, and QA test data. Submitted separately, either prior to or concurrent with the relevant quarterly emissions report. Because we're reporting on a quarterly basis, that gets included in that. If you, in the first quarter, you conducted one of these activities, it is submitted with that report. The results of RADAs, linearity checks, flow monitor, leak checks, flow to load ratio tests, 7-day calibration error tests, and cycle time tests must be reported. So any QA activity. The results of fuel flow meter accuracy tests for combustion turbines, for example, and primary element inspections are also reported and maintained through there. Test extensions and exemption records. So if you received a grace period or you have a waiver for some reason for a test because of non-operation, you need to include that. Event records with conditional data validation claims. Emissions data. Quarterly reports include daily calibration error tests, and all of those are submitted typically on a CD. Flow monitor interference checks, weekly tests for mercury, hourly operating data, operating times, load bins, heat input rates, hourly records of CO2, NOx, SO2, and mercury emissions. Fuel flow rate, stat gas flow rate, as applicable to the monitoring methods used. All hourly records include monitoring component and or system IDs. Hourly SIMS records are also included. Unadjusted and bias adjusted emission values. You remember talking about that yesterday with the RADA test. Part of that test is a bias, so you want the unadjusted and the raw data and the adjusted data to make sure that that bias is, so you can defend the fact that you've applied the bias appropriately. Method of determination codes, which are codes that are indicated by the data acquisition system, and percent monitor availability. Since we are required to have monitor availability, typically in the state where I'm at, if we drop below 95% monitor data availability, then we start getting warning letters from the state. If we drop down to 90%, then you're looking at fines, penalties. Data quality assurance. This is the ECMPS client tool performs thousands of checks and recalculations of reported data. The client tool checks monitoring plan information, QA and certification test results, and emissions data. The data must meet certain criteria before it will be accepted into the EPA database. So if you are uploading quality assurance tests and information, it will check that data, it will flag it if it is not correct, or if it has been incorrectly, sorry. Note, however, that the QA checks performed by ECMPS have their limitations. So it's only as good as the person puts it in there, and it can't see everything. Monitoring plan and QA data may be submitted at any time. Emissions data reports must be submitted within 30 days after the end of each quarter. Okay. So are there any questions on reporting data or QA testing?
RATA test, what is it?
The relative
Right.
relative accuracy test audit?
Yeah, yeah. What is it? RATA means what? Does it an acronym or something like that?
So a RATA is a series, is a minimum of 9 test runs that is conducted using a reference method system. In this case, in the U.S., it would be your contractor would bring up a trailer, typically, and run their own SEM system, calibrate that system according to the appropriate EPA methodology, and you will do a comparative between that and the SEMS that's installed. And so you have to do a minimum of 9 21-minute test runs. You can do as many as you want. You can only throw out 3. But that test is a live demonstration that your instruments are performing correctly, the whole system. It goes all the way from the tip of the probe through your data acquisition system. So that's what that audit is. That is done on a typically an annual basis, but it can be extended out to as much as 8 quarters or 2 years, and a grace period depending on the type of unit that you have. But typically for a unit that is base loaded or running all the time, that would be conducted on an annual basis. RADA stands for Relative Accuracy Test Audit.
Sir, in India we are following a norm that's our Central Pollution Control Board is taking all the data directly from our analyzer without any medium. It's collecting the data directly from our analyzer. What's the picture in US? Are they taking the data from analyzer, the regulatory? Is there any system in between, or is it going to a PC and from there it's being uploaded?
So the data is going from the instrument to a data acquisition system as a data logger. So our systems are set up with a separate data logger, right?
But there is a possibility of manipulation in this data logger? Because
Well,
our police,
so, okay, when you say manipulation, you are doing the data acquisition system is providing calculations based on whatever criteria you have to report to. So if you have to, if you're going to do PM SEMS, for example, you are going to enter the equation, the polynomial that you have there, based on that correlation. The data acquisition system is going to do that calculation. But we have to provide those calculations to the regulatory agency so they can see what calculations that we're using. However, yes, it is being manipulated in the sense that it's being calculated. So it's taking the raw signal output, it's correlated to a value. That value is going to be calculated upon that polynomial in the case of PM SEMS. From a NOx system, for example, you're going to take the output of whatever that is from the NOx, whether it's analog or whatever, and you're going to pull that into the data acquisition system. That data logger is going to take that value, which is going to be correlated to a ppm value. That ppm value is going to be used with the other criteria that are necessary to report it either in a ppm concentration basis, pound per million BTU basis, or mass rate, for example. It is being calculated in there. Again, those calculations are included with your monitoring plan. So they are being given to the EPA and to the state authority, and they can review those at any time. So it's completely transparent. From there, the data logger feeds a signal to a computer. So that the computer is where it's being stored. The data is so it takes it in 1 minute data, condenses it down to hourly data. That hourly data will be stored on a PC, but only after it has been calculated. It is not being manipulated other than maybe averaged by your software package. So if you need to report in a 3-hour rolling average, then you can pull up those 1 hour averages and you can calculate it on a 3-hour rolling average basis and provide that information to the regulatory agency.
but in that case, you are first able to see the data. First,
They can come to the site in real time and look at it. They cannot manipulate or touch our equipment at all. They can come on site and they can look at it. They can request the data. We will certainly more than happily provide them the data, but they cannot access our data remotely. They cannot go into our computers. They cannot look at that data. We do not feed them that data except in our required reporting periods.
in other way, we can say that our Central Pollution Control Board in India is a bit more advanced, more stringent.
There are a number of reasons why that's not allowed, why that would not be allowed.
Just let me know. Tell me why you need a component between your analyzer and server. Then you can directly transmit the data to server. Why you need it? Just tell me. Why you want to put another thing between your?
US is doing that. What we are following. We have been following it for years. Why when US has been doing and they haven't yet rectified that system. They are providing it. Why are we?
No, they have different regulations for that. If they are caught, pardon? No, why you want to put a component, additional component? Just tell me why. When you can directly transmit data from them.
They have a much higher, bigger technology.
You know what happens in US? If they are caught, the industry is closed forever. You know? No.
Let's be sincere in it.
No, we can do that also. But why you want to put a component between?
Platform for the cyber attack. It's giving a path. So it's giving a path that we have faced. NTPC has faced, our Purgi plant has faced an AWS cyber attack from China just because of this. Once this is connected to the net, the whole world is able to just access our instrument. Anybody is able to access our instrument through CDCD network because you are connected online.
Yes, sir.
Anybody is able to access they can enter our DCS system. They can enter our DCS system.
Can you put something on this? Prajit?
The same data we
Yes,
are
sir.
also monitoring.
No, your data is transmitted using ISO protocol 765. Yes, okay, okay. So, there, at what point? At what point? Your analyzer? Ah, ah.
Industry is secured. Whatever you're using, same internet service you're using, which is your industry is using, right? So whatever you're using on your laptop, it is secure or not secure? If it is secure, so automatically your analyzer gets secure because it's using the same path of network. It is there, but you compromise your security of network, then you can compromise anything.
Why you want to compromise with your security? If you are not able to maintain security at your end, why you are
If you saying
no, no, if you are following the architecture given by us, and there is no question of breach of any security. There is no question, absolutely no question.
see whatever you're using, like if you're using any equipment, if you're using any element of network element, you need to secure it, right? This is your responsibility, right? If you compromising it, see, as you said, threat is this threat. I'm not denying the threat, but you have to maintain it. Use the firewall, use any sort of security. You create the local path, you create the VPN, anything you can create, right? This is your responsibility, but you cannot say that you are secure, but your analyzer is not secure. So data of the industry is secure, but the data of the analyzer is not secure. Why it is not secure? Yes, you giving the access to the CPC. If MPPC want to access your analyzer, so you allow the MPPC. You're not allowing the person of MPPC. You're allowing the network of MPPC. So only MPPC network can access your analyzer. This is a secured layer between MPPC and you. If it is a threat MPPC side, MPPC will be responsible. This is argument is going on and on and on.
Sir, security of, dollar of investment we are transacting every year, right? In India, there is always a threat, even if it is being done by government of India and all. So if you are assuming it to that extent, even US Army things are being hacked. So that somebody will get into your PM analyzer or gaseous analyzer to do something. What he will get out of it? So everything can be done, but there is a limit. We cannot expect that when somebody will take in my gaseous analyzer, what he will do? He will increase the number.
Your platform is not open, sir. Understand this thing. You are not an open platform, right? Nobody else can access your analyzer without your permission. Right,
It
sir?
doesn't happen. ऐसा नहीं होता है. वो आपको लग रहा है कि ऐसा हो सकता है, ऐसा नहीं होता है. ऐसा जो guideline
Sir,
बनाया.
this is not the hacking. This was the what I say. You are not, if you are not maintaining your network properly, if you're ignoring the threat, so you will be the victim. So your IT team should more conscious about the threat if it is continuously coming on your network. That is the responsibility of IT team to maintain the security and keep secure your analyzer. Sir, MPPC will access your network if there is a spike, if there is a threat, if there is a malware access from the MPPC network, your IT team will inform to MPPC, sir, there is a continuous attack coming from your network. You have sufficient network devices which can maintain the security. Right, sir?
Can you give just example? Have you any time received a threat from MPPCB? Just one example. You or any industry in Madhya Pradesh. When you got any threat from MPPCB? No, you said there is possibility of threat from MPPCB. Just give me just one example, single example. Then why you are saying about we'll solve the problem when it comes here.
It literally means we have good time for lunch now. Let's go have lunch and come back.
Thank you.
Hello, hello, hello.
आज भी ऑनलाइन है क्या?
नहीं ऑनलाइन नहीं, यूट्यूब पे चल रहा है ना ऑनलाइन। यूट्यूब पे लाइव चल रहा है।
ऐसे इसी इस वाला सिस्टम है।
यूट्यूब पे अपलोड हो रहा है पूरा। निकल गए
जो ऑलरेडी एलिमेंट है उसको उसके ऊपर राइट करना। और कॉलम वाइज भी है सर आपके पास?
माइक सर अंदर साउंड वाले से ही पूछना पड़ेगा।
अच्छा,
इसमें कौन सा है? ये वाला है।
हाँ उसी के ऊपर राइट कर दिया बस। तो नहीं
चलो इनसे ही बात करते हैं।